Okay, I have an equation in standard or in general form, and I'm going to go ahead and change it to standard form and then find the center, the vertices, the foci, and the eccentricity, just like the other problem. So first off, this equation is in general form, and we're going to do like a little predicting. What kind of conic section do you think we're going to end up with? Well, we're going to end up with an ellipse, but how do you know? Okay, I can see that I have both an x and a y squared term, both x squared and y squared terms. They're both positive, both the same sign, actually, and they have different coefficients, which tells me that I have an ellipse. So when I complete the square, I should have an ellipse. If I don't, I did something wrong. Okay, so I'm going to group my x's and my y's. Leave some space. Plus y squared plus 4y. I'm going to go ahead and move this 8 to the other side. Is equal to 8. Okay, I need to take out my a value if it's other than 1. So I have 4 times x squared minus 2x plus my a value is 1, so I can leave it. Y squared plus 4y is equal to 8. Okay, so what value am I going to plug in to complete the square? I'm going to take my b value, -2, split it into 2, -1 and -1. Then I can square those numbers to give me my c value, which is 1. So add 1. Over here, start with 4, my b value. Split it into 2, 2 and 2. Square those to give me 4, so plus 4. On the other side, I added 1, but did I really only add 1? No, I added 4 times 1. So I'm going to add 4 plus 1. And then over in the y squared term, I'm going to add 4. So we get 4 times x minus 1 times x minus 1, or we can square it, plus y plus 2 squared is equal to 4 plus 4 plus 8, which is 16. Now I need to get a 1 on this side, on the right side. So let's go ahead and divide the left side and the right side by 16. So divide by 16, divide by 16. And I get 4 divided by 4 is 1, 16 divided by 4 is 4. So I get x minus 1 squared divided by 4 plus y plus 2 squared all over 16 is equal to 1. That is my equation in standard form. All right, let's go ahead and get our a and our b. So our a value is the larger one. So a squared is equal to 16. So a is equal to 4. And b squared is equal to 4. So b is equal to 2. Our center is our h and our k. So 1 comma -2. And I'm going to go ahead and graph that in. Let's really get a little sketch. So 1. Okay, that's my center. From my center on the major axis, which is vertical this time, I'm going to graph 1, 2, 3, 4, and down 1, 2, 3, 4, and then to the right 2, 1, 2, 1, 2, and I have an ellipse that looks something like this. Okay, for my eccentricity, we have the c value over the a value, so I better find my c value. So c squared is equal to a squared minus b squared. I can see that a squared is 16 minus 4, giving me 12. So c squared is equal to the square root of 12, which is less than 4 and greater than 3. So I'm going to count out 1, 2, in between 3 and 4. Okay. The foci, I always start with the center at 1, negative 2, and then I'm going to change to adding and subtracting to the y, so plus or minus root 12. So let's start that answer. 1, negative 2 plus or minus square root 12 are my foci here. And lastly, my eccentricity. So E is equal to root 12 over A, which is 4. So that gives me root 12 over 4. Ooh, that's going to be pretty close to 1, I believe. So like 3 point something over 4. I don't have a calculator, so you guys are going to have to do that one on your own. Okay. All right, next. So I have the equation of an ellipse given the following, and then I want you to sketch, I would recommend you sketch the ellipse. So the vertices, which are on the major axis, are at plus or minus 0, plus or minus 20, and then the eccentricity is 1/10. So I am going to sketch it. 0, I'm just going to call that 20 and negative 20. And then, so the things that I know is that since the vertices are on the y-axis, that this is a vertical ellipse because that's the major axis. Okay. The center should be in between the vertices, so it's at 0, 0. And my A value is the distance from the center to my vertices, so 20. Okay. We'll figure out our B in a minute. And then I actually can figure out my C value. So what other equation do I have that uses like E and C, and well, E is equal to 1/10, which is equal to A over C. But other way, sorry, C over A. But I can see that my A value is not 10, it's 20. So if I multiply this equation by 2 on the top and the bottom, okay, I get E is equal to 2 over 20, which matches my A value. So C is equal to 2. Okay. So if C is equal to 2, what's my B value? Let's see. I can use this equation. C squared is equal to A squared minus B squared. C is equal to 2, so 2 squared is equal to 20 squared minus B squared. I will add B squared to both sides and subtract 2 squared from both sides. So B squared is equal to 20 squared minus 2 squared, which is 400 minus 4, okay, which gives me 369, which is about 19.9. Okay, so my B is equal to 19.9. So I'm actually going to count out if that's 20, 19.9. We know that already that the shape is going to be pretty circular since the eccentricity is 1/10. It's pretty close to 0. Okay, so we can write the equation. X minus 0 squared over B squared, because my B value is 19.9 and that's horizontal, so 19.9 squared. Actually, even better, we're going to put 369, okay? Plus y squared over 20 squared, which is 400, is equal to 1. And we are done. That is ellipses.